Okay, this next video is on ellipses. So our essential question, how do you find equations of ellipses and graph them? All right, so we're going to talk a little bit about some characteristics of ellipses. So the definition is that an ellipse is the set of all points. So the points that they're talking about there are all the points that would be on the ellipse. I have one example right here. In a plane such that the sum of the distances from P to two fixed foci is constant. So if I take this distance and add this distance, it's going to be the same no matter where I am on the ellipse. So if I go to right here on the ellipse, the distance between that point and F1 plus that point and F2 is the same as the distance between this point and F2 and the sum of F2 and F1, those distances. So no matter where you are, the sum of those two distances will be the same for all of those points. So that's what it says down here. This is another characteristic, is that sum of those two distances also happens to be equal to 2a. So just think about if that point was all the way over here. So I have the distance from here to F1, and then the distance from here to F2, and that distance happens to be the same as this distance. So when I add this piece together with that piece again, it's going to give me the whole distance between those two vertices. We'll talk about that a little bit, but those are called the vertices. So it's 2a. The sum of those two distances is equal to 2a. There is a YouTube video that kind of explains that a little bit. They show on patty paper how you can take a circle and some fixed points and create an ellipse. So that's kind of fun to watch. And then they also explain this definition and animate these distances changing as that point P moves around the circle. So if you're interested in watching that, this is the video link right down here. So you can pause the video, write it down, and then type it into your web browser to see that video. One of the things that I usually like to do in class is explain some examples of where the ellipse comes from, or what kind of characteristics the ellipse has. So there is this YouTube link right down here, and what that does is it takes you to the part of a tour of the U.S. Capitol building in D.C. And in that room, part of this tour takes you to the spot where John Quincy Adams had his desk when the room was actually their chamber. And they talk about the fact that the room is in the shape of an ellipse and how he could hear his opponents who were sitting on the other side of the room because of where they were located. And because he knew that he could do that, he didn't have any important conversations at his desk. He always took them someplace else so that they could not hear his conversation. But that's a really interesting video. I actually took this tour, and it's really nice. The tour guide comes over here and then talks in a low, normal, but low kind of voice, and you can hear them as if they were standing right next to you on this side of the room. So that's kind of fun to watch. Another case would be the Museum of Science and Technology in Chicago, Illinois. They have this particular room here, which is also oval shape. They have these 2 points, which happen to be the foci of that ellipse. And one person can stand here and face this shield and talk in a really low voice. And then the person on this side facing that shield can hear them as if they're standing right next to them. So that's kind of a fun thing also. But both of those demonstrate the characteristics of the ellipse and what I was talking about on the previous slide with those 2 focal points and any point P on the ellipse. So I am not going to go through all of this. This is just a derivation of the formula. So it's taking the idea of those 2 distances, the sum of those 2 distances, equaling 2a. So we actually label them with some points, and these are the typical points. We use an XY for the P, we use C0 for the first focal point, negative C0 for the second, and define the distances between the point P and each of those focal points, each of the foci. Then you go through a whole bunch of algebra, and this will be on the PDF version if you wanted to look at it more closely. And it develops the equation of an ellipse. So the equation of ellipse is x squared over a squared plus y squared over b squared equals 1. This is one version of it. This is when the ellipse is horizontal. If you have a vertical ellipse, this changes a little bit. And so that's what we're going to talk about on the next slide, are the different parts and how to identify them and get them out of the equations. So here are some key ideas. So the foci are always on the major axis, and the major axis is the long axis. So if you're looking at these two types of ellipses, the major axis would be the horizontal in this case, and in this case, the major axis is the vertical. It's always the long axis. And then the midpoint of the major axis is the center of the ellipse, and the endpoints are the vertices. I can get that to pop up. There we go. Okay, so these are the 2 points that we call the vertices, the endpoints of the major axis. When we talk about the minor axis, the shorter one, I just call them endpoints. So the points at the end of the long are called vertices, and then these other 2 points are just the endpoints of the minor axis. So we'll talk about the different pieces. So let's see, let's start with our equation. So the equation of this one is going to be x squared over a squared plus y squared over b squared equals 1. And the idea here is that the a is bigger than the b. The a is the point. The a is the point of those vertices on the major axis. So it's whatever the distance is from the center to the vertex or vertice. Okay, from the center to that vertice. Okay, so between the 2 vertices, it's the distance from the center to that vertex. That is the A value. The B value is the value at the endpoints for the minor axis, the distance from the center to that point is the B part. And so visually, the A comes from the major axis, which is the long one, and the B comes from the minor axis, which is the short one. So A is bigger than B. So then if we're going to label our vertices, as I've done up here, it would be A comma 0 is one vertice, negative A comma 0 is the other one. Okay, so those are our 2 vertices. Endpoints are from the minor axis, so that's 0b and 0 negative b. Make sure you get your zeros in the correct spot, whether those values are on the x or on the y axis. And then the foci we call c comma 0 and negative c. So those are the values we use for the foci. And the foci are located on the major axis inside the ellipse. Okay. To find the foci, we use this calculation. C squared equals a squared minus b squared. So it's always the large minus the small, and it'll give us c squared. So you take the square root of that difference, and that's how you're going to find c. And we'll do some examples here in a little bit. Now let's look at the vertical ellipse. So the major axis is now on the y-axis. And we're going to still use the A labels for that. The B values are still on the minor axis. And then our foci we still call C, and they are still located on the major axis inside the ellipse. So the equation of the vertical ellipse is x squared over b squared plus y squared over a squared equals 1. Again, a is bigger than b. So when you're looking at an equation, you need to find which of those two denominators is the larger number. That is going to be your major axis. So in this case, a squared, which is the value bigger than b, that is going to be my major axis. It's going to be on the y-axis. So that's one way to help you remember where the major axis goes, wherever the bigger number is. Now with an ellipse, this is a plus. So that's important to note that the ellipse is adding and the bigger number is where our major axis is located. So the vertices in this case would be 0a and 0 negative a. Notice the 0 is in a different spot than before because the major axis is on a different axis than it was before. The endpoints, b0, negative b0, and the foci, 0c and 0 negative c. The foci are found the exact same way. We take the large value, a squared, minus the smaller value, b squared, and that'll equal c squared. So you can take the square root to find your c value so you know where the foci are located. All right, let's take a look at some examples. All right, so they give you some information. In this particular case, our ellipse is at the origin, so the center is at 0, 0. One vertex is at 0, 5, and one foci is at 0, 2. Now, with all this information, we can find the other vertex and the other foci because the center is at 0, 0. So the other vertex is in the opposite direction at 0, negative 5, and the foci is in the opposite direction at 0, negative 2. So one vertex at 0, 5, my other vertex at 0, negative 5, and then my foci at 0, 2 and 0, negative 2. So then I need to find the other endpoints. So to find the other endpoints, I'm going to use the c squared equals a squared minus b squared. So you plug in the numbers that you have. So we have the c from the foci, and we have a from the vertex. Calculate and find b. And so we get square root of 21 for b, which is approximately 4.58. I just wrote the decimal part down so that I can identify where the point would be a little more accurately than just looking at square root of 21. So then I can identify my endpoints, square root of 21, 0, and negative square root of 21, 0. And so with all that information, we can write the equation of our ellipse. The long side is going to be on the vertical axis. That's our major axis, so the larger number must go under the y. And so we graphed it and wrote our equation. Now another type of example, finding the coordinates of the foci and graphing the ellipse. And then after we do that, we'll identify the domain and range. So when we are doing a graph from an equation, first thing you need to do is make sure that the equation equals 1. This does not equal 1 yet. So I have to divide by 100 so that I can get it equal to 1. Remember, the general formula always equals 1. So I divide by 100, simplify the equation. Then from that, I can start identifying the different pieces, like my A and B. In this case, I actually wrote it out as the vertices. They're going to be at 5, 0, and negative 5, 0, because 25 is the larger number. The 25 is also under the X, so it should tell you which direction it's going to go. It's going to be a horizontal ellipse. I can identify the other endpoints at 0, 2, and 0, negative 2. Then we can calculate our foci using the c squared equals a squared minus b squared. So this time I have a squared and b squared, so I subtract square root. That gives me the foci. Let's take a look at this point at the diagram. So everything is all plotted on there already. So my vertices, my foci, you can see the little dots on the inside, and then the other endpoint, so that's the ellipse. And then from that, we can identify our domain and range. So the domain goes from -5 to +5. The range goes from -4 to +4. It's an ellipse, so it's bounded by those values, those endpoints. So none of the ellipse is going to go past that. Same thing with this other example. It's just an example of the ellipse going the other way. Notice that the 49 is the larger number. It's under the y, so this is going to be a vertical ellipse. In this case, all I did was identify the A and the B. It didn't ask me specifically for the vertices or the endpoints, so I'm just identifying A and B so that I can identify the foci number, C. So I have A, B, and C. And then I'm going to use all of that to help me identify the foci and the domain and range. So the foci would be 0, plus and minus 2 square root 2. So when I graph it, let me see. A is 7, B is 3. There we go. I had to get in the right number so I could find it. You can see the foci on the inside of the ellipse and using that ellipse to identify your domain and range. All right, so just one more example. This one involves an h and a k. So just like when we were doing the parabolas and we had an h and k, anytime you have x plus or minus a number and y plus or minus a number, that gives you an h and k. So for this first one, it's x minus h. It's still minus here, so that means my h is a -7. This would be y minus k, so k is a +5. And then you can also still think about this first term as being divided by 1. So we still need an a and a b in the denominator. I find the larger number gives you a. So I have my center, hk, so that's going to be -7.5. I have my a, which is the square root of this larger value, so that's going to be 3. B is the square root of the smaller value, so that's going to be 1. C, you're going to calculate using the c squared equals a squared minus b squared. We get 2 square root 2. And so now that we have that, we can identify the vertices, the foci, and the other endpoints so that we can graph it. So the main idea here is to be able to graph this ellipse. And so you have to identify all the parts. So the vertices will be at -7, 2. Oh, that's the whole thing. And -7, 8, which is up there. The foci, -7, and you have to notice your center is not at 0, 0. So you're going to have to add the 2 square root 2 to the 5, which was this number, and subtract it from the 5 because it's the y value that's going to change there. So it's approximately 7.8 and 2.2. So I have those values also marked. And then the endpoints, which are -6.5 and -8.5. So the endpoints are in the horizontal direction, so I am adding and subtracting the b number from -7. So what I did is I plotted the center first, and then it makes it easier to move to the left, move to the right, move up, move down, and then identifying your foci in there as well. So that's how you would use the equation, finding all the parts, and then graph the ellipse. So here's just a summary slide, reviewing some of those things we talked about at the very beginning, talking about the major axis being horizontal or the major axis being vertical, and then the equations when your center is not at 0, 0, when you have an HK center, and what they would look like in that case. So if you have any questions, all of these will be on the PDF format. Just send me an email and let me know, and I will have the assignment posted on Google Classroom.